Welcome to my science tutorial. In this video, we are looking at auto-ionization of water and calculating H plus and OH minus concentrations. Alright, so let's get started. Now, there are some few things that we have to take note of. Water is amphoteric. Water is amphoteric. What does that mean? Now, what you have to know is that few water molecules, if you have water as a stock water, few of the molecules of water will act as bases and some will act as acid. So if that is the case, then we'll say that water is amphoteric. So if we take H2O plus H2O, both liquid, now what is going to happen is that these water molecules are going to be in random motions and sometimes they collide, and occasionally the collision is strong enough to allow one of the water molecules to rip a proton from the other. And if that happens, then we're going to have H3O plus hydronium ion, and OH minus hydroxide ion in solution. So that is what happens in water. If you want to show the structures, then it is O bonded to hydrogen, hydrogen with two lone pairs of electron, and then another of O bonded to two hydrogens with two lone pairs of electron. So at the end of the day, we're going to have oxygen bonded to hydrogen with three lone pairs of electron, and as a result carrying a negative charge. And then we have the hydronium, which is oxygen bonded to three hydrogen atoms with just one lone pair, and this time having a positive charge on it. So this is what is known as auto-ionization of water. Auto-ionization for water. Now, when we consider the ionic product constant, we'll say that Kc is equal to concentration of the hydronium times the concentration of the hydroxide. Okay, so this is a formulation that shows the relationship between the individual water molecules colliding and resulting in the hydronium and hydroxide ion, but we're not going to write that divided by the concentration of the water molecules. We'll write only the products. So with this particular one, it has a special name which is known as Kw, which we are going to refer to as um, equilibrium constant of water. So equilibrium constant. Okay, so it's a Kw once again is equal to H3O plus concentration times OH minus concentration. Now this is standard at a temperature of 25 degrees Celsius. At a temperature of 25 degrees Celsius, we'll say that Kw is equal to 1.0 times 10 exponent minus 410. Okay, usually we don't write the unit, but well, how do we use this to calculate the hydronium concentration or H plus concentration as well as OH minus concentration? Let's consider this question. The question says that calculate the value of H plus concentration and OH minus concentration in a neutral solution at 25 degrees Celsius. Now, they're talking about water here, so what we have to do first is to write the auto-ionization of water, which can also be written as H2O in equilibrium giving us H plus OH minus. Okay, now the Kw we said is equal to the concentration of H plus and the OH minus. Okay, now Kw, so we say but Kw is equal to 1.04, oh sorry, 1.0 times 10 exponent minus 14, which is something that you have to know of it. Okay. So what we are going to do is to put this into the equation of Kw. So this is 1.0 times 10 exponent minus 14 equals concentration of H plus times the concentration of OH minus, right? So this is the expression. Now, another thing we have to know that when it comes to a neutral solution, the concentration H plus is equal to the concentration of OH minus. Okay, so these are supposed to be equal in a neutral solution such as water. So this will be represented by X in this equation. So when we look at this equation, let me call it A. When we look at this equation right here, we will say that Kw, which is now 1.0 times 10 exponent minus 14, is equal to X times X. Okay, so we will say that 1.0 times 10 minus 14 is equal to x squared. So all we have to do is to take the square root of both sides, and our x will be equal to the square root of 1.0 times 10 exponent minus 14. Okay, to the square root of this, and we'll have x to be equal to 1.0 times 10 exponent minus 7 molar. Okay, so this becomes the concentration of H plus as well as the concentration of OH minus, okay, equals 1.0 times 10 exponent minus 7 molar, right? So when we take water, we say that the concentration of the H plus and then the hydroxide is equal, and that value is 1.0 times 10 exponent minus 7 molar. I will advise that it should be something that is supposed to be offered. So you have to know it offered as well. Okay, then let's take note of this that in acidic solution, the H plus. So when we take acidic solution, in acidic solution, the H plus concentration is greater than, should be greater than 1.0 times 10 exponent minus 7. The when in basic solution, we'll say that the OH minus or the hydroxide concentration, the hydroxide concentration should be greater than 1.0 times 10 exponent minus 7. Or in other words, we'll say that in a basic solution, the concentration of H plus is less than 1.0 times 10 exponent minus 7 molar. Okay, so what does that mean? Well, we have H plus concentration to be equal to OH minus concentration, then that solution is what? Neutral. If we have H plus concentration to be greater than OH minus concentration, then we say that that solution is going to be acidic. When we have OH minus concentration to be greater than H plus concentration, we say that that solution is what? Alkaline or basic. Good. So let's look at this question. This question says that calculate the value of H plus concentration in A. A says what? A solution in which OH minus is 0. We have OH minus to be 0. So let's put that here. Solution. We have OH minus concentration to be equal to 0.010 molar. And we are supposed to find the value of H plus concentration. So H plus, let's put a question mark here. We'll use the Kw expression, which says that H plus concentration times OH minus concentration should be equal to 1.0 times 10 exponent minus 14 molar. Okay, so H plus here will be equal to 1.0 times 10 exponent minus 14 divided by what we are given for the hydroxide concentration, which is 0.010, and this will give us what? It will give us 1.0 times 10 exponent minus 12 molar. Okay, exponent minus 12 molar. So when we compare this, we compare this value to, when we compare this value, or when we subtract it from the concentration, we'll find out that the hydroxide concentration is greater than the H plus concentration. So this is the hydroxide concentration, this is the H plus concentration. When we compare it, we'll conclude that H plus is less than OH minus concentration. And so how do you think this solution will be? Will it be acidic or basic? Solution is going to be basic. Now let's consider the other one. B says that a solution in which we have OH minus concentration to be equal to 1.8 times 10 exponent minus 9 molar. We are supposed to find the H plus concentration. You can pause the video and try this for yourself. So H plus concentration is going to be equal to 1.0 times 10 exponent minus 14 divided by 1.8 times 10 exponent minus 9. Okay, so H plus will be equal to 5.6 times 10 exponent minus 6 molar. Okay, so that's going to be the concentration of H plus. Now, when we compare this value to what is given us as the concentration of OH minus, we can clearly see that the value of H plus concentration is higher than this one. And so we'll say that H plus concentration greater than OH minus concentration. And so resulting solution is going to be acidic. All right, so that's how you go about auto-ionization of water and calculating H plus and OH minus concentration. I hope this video is useful. Check our playlist for the other videos on acid and bases. Thank you.